quality of service helps to prioritize important traffics so that those important traffics will be delivered on time, like voice, video, streaming data, instant messenger data. They're all time sensitive. If it is delayed, then it is no use of delivering it. Such traffics need special service. So in short, what I'm trying to say is, in network, there are different type of traffic pass through the same wire. Same wire, but different type of traffic. See, in cities, you don't have one common road for everyone. There is one lane for people who want to walk and go. There is one lane for only cyclists, people who go in cycle. No motor, just cycle. And there is another lane meant for bikes. In most of the countries, we can see a separate lane for two-wheelers, if two-wheeler is allowed in that country. In some part of Bangalore and some part of Chennai, you can see a separate lane for two-wheelers alone. Three or four-wheelers can't come there. And there's a separate lane for four-wheelers and another lane for heavy vehicles like lorries, buses. Why? So that they will not get disturbed. If everyone goes together, that becomes a problem. For example, these bikes and small cycles, they can easily go through small gaps. So what they do, they come and block all the small gaps, so the four-wheelers can't move freely now. Now, four-wheelers will be much delayed if you mix this two-wheeler and four-wheeler in same lane. That's what we see in India, most of the places. There is no separate lane for four-wheeler. And this all two-wheelers will come and fill all the gaps in the signal. And when signal opens, only two-wheeler will have place to go and four-wheeler have to wait. By the time the again red signal comes, makes us to stop. So there's need for a separate lane for two-wheeler so that there won't be a disturbance to four-wheeler and vice versa. Likewise, the size of the data that travels is not the same. File transfer protocol, FTP, you are transferring file. That is going to be a very big amount of data. But the voice that is coming from my laptop to your laptop now, they are tiny packets. While sending out only, my laptop is sending as a tiny packet so that it can easily go through small gaps and reach you as early as possible. That is not the case with the TCP packets like FTP. Their size are very big. The payloads are very big. This voice payload and data video payloads, they are all very small. So there is a need for separate treatment, separate prioritization, so that those tiny packets will never get lost. Say, for example, when there is a railway cross, in villages I see there is a railway gate and people have to wait a long time for the train to come and pass through the area. And then the gate will open and this people can go to the other side. It's most of the places I see that in village side. Wherever there is a railway track, there is a railway gate. And before train comes, they close it and you have to wait till the train pass. After that, one guard will go and open that gate. Only then they can pass through. That's a very poor service. That's a poor service. You should put a underpass or overbridge to avoid that wait time. Likewise, in QoS, like a train, a big FTP is going, consuming all the bandwidth. This poor voice packet, tiny packet, need to wait till the whole TCP FTP packet finish going to the other side. By the time the voice packet gets delayed a lot, on the receiving side, they will face a lot of problem. When my voice is interrupted in the middle because of FTP, what will happen? You will not be able to listen my voice continuously, and you will think that I got disconnected, and you will also disconnect and go. But actually I am connected. It is because of my voice getting delayed. You feel that I got disconnected, which should not happen, which means there is a need for prioritization. QoS is providing a quality service according to the need. You make the router to provide service based on need. By default, routers do not know to differentiate from one traffic to the other. Routers don't care whether this is an ICMP or FTP or RTP or a SIP. It never cares about the type of traffic. By default, QoS never cares about what type of traffic. According to routers, by default, FTP and RTP are same. This is also data, that is also data. But after QoS, the routers get that visibility, the knowledge of differentiating the traffic and providing different type of service. That's what QoS. We educate the router to differentiate the traffic and provide different levels of service. That is quality of service. For example, when there is someone with heavy load in their hand, waiting to take ticket in a big queue, if that person with a heavy load will be provided ticket, maybe taking him to the to the front of the queue, or creating another queue for those people who are having heavy luggages, or something like that, like, okay, let me put it in this way. There is an old person who cannot stand for a long time, is standing in the queue. The moment someone notices that old man, that someone takes that old man to the beginning of the queue so that he gets the ticket next and goes. That is quality of service. Identifying the vulnerability and providing the service. Like that old man or old woman, this network also have got a lot of old men and old women, like voice and video. They cannot tolerate delay for long. The delay should be less than 300 milliseconds. Means between my laptop and your laptop, the time taken to deliver my voice should not be more than 300 milliseconds. If it is more, then there will be a voice break. You don't experience any break. It means you receive my voice in less than 300 milliseconds. That's why your ears couldn't identify the delay that takes in between my place to your place. Less than 300 milliseconds need to be guaranteed. So on the path, voice has been prioritized. That is why you are listening to me without any break. It's not the same level of service provided for other traffics like FTP or TFTP. So all the time sensitive traffics, and then next is the management traffic like SSH, Telnet. They are more important than FTP. So they need to be provided priority than normal FTP. The reason is they are management traffic. If something is going wrong with the router, I should be able to immediately log in using SSH or Telnet. If I am delayed logging into my router, then attacker may finish my router, take it under his control. So when an attack is going on, when my CPU is a victim, as soon as I identify my router is getting attacked by someone, I should be immediately able to log in, take control. If router says, no, I'm already busy, I cannot take your SSH request, then there is no quality of service. Then attacker will be keep on using my router, doing all the nasty thing that he is already doing, and I will not be able to stop it. As soon as SSH comes in, it has to stop all the work that it is doing, the router is doing, and give the processor to my SSH data so that I can take control and stop the attack that is going on. For that, QoS is needed. So quality of service is making the router to understand different type of traffic, differentiate different type of traffic, and providing different level of prioritization. Now this is done with one of the queuing method called fair queue. Whatever the spelling, fair queue. Fair queue, FQ, fair queue is a queuing method, a dynamic queuing method. I repeat, fair queue. If you go and enable fair queue on this router, let's say gig 00, simple command only, just go inside this interface and say fair queue. That's it. When you put that command, what happens is it starts creating queues, and if there is a 5 session, all these session, if there is a 5 flow, 4 flows, each flow will get equal amount of bandwidth. That is fair queue. How is the flow identified or defined? Source, let's say this is coming from computer A, this is coming from computer B, this is coming from computer C, this is coming from computer D. The source address is different, you see, which means it is 4 different flow. So each flow will get equal amount of bandwidth, meaning you got 1 gig, then you got 2500 meg, 250 meg each. So there is going to be 4 queues in this physical pipe, there's going to be a 4 queue created, each queue of size 250 megabits. A will use 250 megabits, B, C, D. So, no one disturbs the other. They don't disturb others. They have their own reserved path, bandwidth. It's not A consuming too much and B suffering. It takes the actual bandwidth and divides it and gives to each flow, divides it equally. And these queues are dynamically created. So in case if there is another flow trying to come, so this goes down to 200 each. 200 each. Immediately, the queue gets created for the fifth guy, and the bandwidth is equally given. 200, 200, 200. This is one of the QoS called fair queue. Very old method. But the problem here is this is not allowing you to classify, allowing you to set any priority level. This is dynamic. What if there is too many flows and they all get some equal amount of bandwidth, which is not sufficient for voice? Assume this E is coming and E gets 200 meg, which is not sufficient, and this is voice. Very important. Very important. Why? Because it is time sensitive. Usually voice traffics are too tiny. Just for example, I'm saying if it is more than 200 meg needed, but only 200 is given, what will happen to the rest of the traffic above 200, the voice traffic? They all will be delayed and get tail dropped, which is not an acceptable one. That's the problem with fair queue. Fair queue is dynamic queue. If you have 50 flows, this 1 gig is divided 50 times and given to each flow. User don't have control over the number of queues and the amount of bandwidth for each queues. We don't have any control. So this queuing method, not seen much. This is one old method, fair queue. Do you understand what is fair queue?
Yeah, right.
Right. So quality of service is creating queues and placing the traffic inside the queues so that one traffic won't affect the other traffic. And the first method, what you saw here, is fair queue. There are various other methods like weighted fair queue, class-based weighted fair queue, priority queue, and low latency queue. These are all the different type of queuing method that we have. But before we go into this weighted fair queue, we need to learn a few more things. So we will go to the topic called marking. So let me repeat. I just gave you an introduction to what QoS is, and to get an idea how QoS works, I took one example from various queuing methods called fair queue, so that you will get an idea what this QoS is actually doing. It creates queues. If there is no queue, then always fight. You might have seen that in various places. Why they ask you to form a queue? Why they put a separate queue for first class and business class and the premium class, and for the economic class, zone C, zone D, zone A? Why they do this, all this queuing? So that the service can be given to the best. If not, clash. Even those people, so-called educated people, will make one nonsense fight which cannot be digested in publics when there is no queue. So there is need for a physical queue to be maintained. They don't maintain mental queues in their mind. Wherever that lacks, so they need a physical queue. They do it. Now, let's talk about a few more terminologies, then we will come back later to this different type of queuing. Marking. What is marking? As I said now, first class, business class, economic class. In that economic class, zone C, zone D, zone B, zone A, these are all markings to identify group. First class group, business class group, zone D. People who sit at the back of the plane need to be loaded first, boarded first, so that they won't be on the way blocking. So zone D, and then zone C, and then zone B, and then zone A. So that marking helps them. The zone marking, the first class, the business class, the premium class, this type of marking helps to identify the group. According to the group to which they belong, the service varies. Isn't it? Will the economic group and the first class group get the same service? No, they don't get the same service. They don't get the same service. So different group get different service, not the same service. That is what happens when you have marking. You will be able to provide different prioritization based on the marking. As soon as they see, in the olden days, they used to put tag on our hand baggage, first class, business class. So from far distance, this ticketing people will know, that boarding people will know, that check-in people will know that we need special service. They will come and help us. That marking helps likewise. In layer 2, we have 3 bits for marking. In layer 3, also we have 3 bits. We also have 6 bits. You can use any one. So, using 3 bits, you can have 6 or 8 different type of service. 8. All 0 means what? No QoS. Now, this is the least This is the most important. So we get different type of marking, 8 different type of marking. When you don't have QoS enabled, it is 000. What does that mean? It means that best effort. It means that first in, first out. Simple. Whichever comes to this interface has got a queue, hardware queue. Gig Ethernet 0. Anything that enters first will leave first. That is default, FIFO. When you have 0000, there is no prioritization. There is no queuing, there is no prioritization, nothing. But we can also do marking like this. This is also called as weights. You see? Weighted fair queue. In this normal fair queue, you don't have any weight. Whether it is A or E, treated the same way. In some local flights, you don't have first class or you don't have premium class. Only one class. Only one class. So they get equal priority, same priority. I will also get cashew to eat as a snacks. He will also get cashew to eat as a snacks. Equal priority. But when you have weight, I will get only water. But he will get something different, which is a $100 worth. Free drink for him. For me, for water itself, they will see up and down and give. But this fellow just got into the flight and immediately asking water. So that is weightage. Weight. Now, this is what decides how to prioritize. If a traffic is coming with this marking and also this marking, which to give more importance is decided. This will get more important than this. Weight. So, based on the weight, the queues will be prioritized. Not only that, if there is a need for dropping. In olden days, they will do over ticketing. If there is 300 seat in flight, they will take 320 bookings, thinking that some 20 people won't come. Unfortunately, I'm there. But when I am there, there is also 2 more other guys there. 300, 299 booking, 299 boarding pass is issued. But in the counter, we 3 are there. Only 1 seat available in the flight. We 3 have got valid ticket. They overbooked. The airlines carrier have overbooked. 3 people are in the counter, but only 1 seat is there. 299 is already checked in. This happened in Dragon Airways. Only 1. They said only I will fly, the other 2 will be dropped. And the other guy was asking why. We 3 are here. If you give to all 3 of us, or you don't give to any one of us. But the airlines, they said, he has got more weightage. He has to how? See the sequence number. The booking sequence number also matters. He booked 2 days early before you booked. His sequence number is early than yours. Ticket booking timing also matters. So now that guy is begging me, sir, please let me go. For me, it's very urgent. I need to reach on time, all those stuff. And then I said, okay, fine. Give my seat to him. Put me in next flight. They put me in next flight for the same cost via Malaysia to Shanghai. Instead of going through Hong Kong, I was going through Malaysia. So weightage matters. Same thing happens in networking. When there is a congestion, there should be some drop. Only then the congestion can be controlled. But which one to drop? The packet marked with 2 will be dropped, not the one with the marking of 5. To avoid congestion, the packet marked with 2 will get dropped, not the one with marking of 5. You understand why weightage is needed? Weighted fare queue is better than fare queue.
Yeah.
So weighted fare queue has got weight. Based on that queuing, this is also a dynamic queue, but when there is need for a drop, when there is a wait, router knows which one to drop to avoid congestion, to control the congestion that is happening. Yeah. So that is weighted fare queue. We'll talk about this class-based weighted fare queue, PQ, and low latency queue later after learning these things in detail. We have just seen that layer 2 uses 3-bit and it is called as class of service. Layer 3 also uses 3-bit, which is called as type of service. And this one with a 6-bit is called as differentiated service code point, DSCP. So after thoroughly learning these 3 things, then we will get back to class-based weighted fare queue, PQ, and low latency queue.
Okay.
I hope this QoS is an interesting topic for you. And